I'd like to now look at double angle formulas for trig functions. These are used when we don't necessarily know the trig function values for the double angle, but we do know the trig function angles for the single angle. There are three basic formulas that we will use. Several of these have different alternations if we want to use them. The first one, sine of a double angle is equal to 2 times sine of the single angle times cosine of the single angle. Do make sure that you notice that you're inputting different things into your function. In other words, on this one, the angle is doubled, and then on the right-hand side, the angle is single. Okay? Cosine has three different variations for its formula. You can either use cosine squared of the single minus sine squared of the single, or you can use 1 minus 2 times sine squared of the single, or 2 times cosine squared of the single minus the 1. Tangent, you have two different formulas for. You can use this formula, or you can use that formula. The second formula is nice if you've had a problem where you've already found sine of the double angle and cosine of the double angle. We know that tangent is just the ratio of sine over cosine. As long as you're talking about the same angle, you could use that ratio. If you have a problem where they're simply asking for the tangent of the double angle, then probably this first formula is the better formula to use. You may want to take a moment, pause the video to write down these formulas. Alright, I'd like to actually look at an example. Okay, this example says if cosine of theta is equal to negative 2 over 5 and theta lies between pi and 3 pi over 2, they want us to find sine, cosine, and tangent for the double angle. Now, it turns out I don't honestly care what the angle is. All I care about is they gave me information about the single angle, and now they want me to find information out for the double angle. Given what I have here, it's enough for me to figure the question out. Okay, first thing, go ahead and draw your information so you can better see what we're talking about. You've been given that cosine is negative 2 over 5, and you've also been given that theta is in between pi and 3 pi over 2. Well, that information tells us that I'm in quadrant 3, and so let me go draw a triangle in quadrant 3. Cosine being negative 2 over 5 tells me that my r value is 5, and my x value, because I'm in quadrant 3, is negative 2, and I don't know what y is. I can find y, though, by using Pythagorean theorem. Let's go ahead and do that. I know what x is. I don't know what y is. I know what r is. Alright, y is going to end up being plus or minus the square root of 21. Because I am in quadrant 3, y will equal the negative value, square root of 21. Okay, now that I have that, I can go on and I can find the values for sine of the single angle. I'm sorry, the double angle. This angle right here that we're talking about is theta. They want the sine value for 2 theta, and the cosine value for 2 theta, and the tangent value for 2 theta. Okay, what we want to do is we want to use our formulas. Okay, number 1, they wanted us to find the sine of 2 theta. The formula for sine of 2 theta is 2 times sine of the single angle times cosine of the single angle. Well, the single angle is the one that we have drawn, and we can figure this right-hand side out. It will be 2 times sine of the single angle. We know that's y over r. The y value is negative square root of 21. The r value is 5. Cosine of the single angle is x over r, so that will be negative 2 over 5. Okay, let's go ahead and simplify that out. The 2 I'll put over 1. You see on the top we have 2 negatives, so that multiplies to a positive. You have a 2 times a 2. This will be 4 square roots of 21 all over 25. Whatever the angle is, that's the sine of double that angle. Alright, let's work on the next part. We need the cosine of the double angle. Well, we have a choice of equations that we can use for cosine of the double angle. Pick one. Let's say in this case we pick 2 times cosine squared of the single angle minus 1. I generally like to pick one that only has one trig function in it so that I don't have to perform as many operations. Okay, this is 2 times whatever value you get for cosine of theta squared, and then we'll subtract off 1. From above, cosine of theta, we can see from looking at our graph, cosine is negative 2 over 5. And so we'll put negative 2 over 5 in place of cosine theta. Okay, now we have to square first, so this would be 2 times 4 over 25, and then minus 1. We'll go ahead and multiply our fractions. We'll have 8 over 25 minus, and instead of saying 1, I know I need a common denominator, so I'll write 1 as 25 over 25. Alright, 8 minus 25 is negative 17 over 25. This is the value of cosine of the double angle. Alright, finally, on this particular problem, it asked me to find tangent of the double angle. Because I already know the value of sine of the double angle and cosine of the double angle, I will use this formula. Alright, the value that I found for sine of the double angle from above, I believe, was 4 square roots of 21 over 25. The value that we just found for cosine of the double angle was negative 17 over 25. Now we need to simplify this fraction. I will do that by keeping the first fraction just the way it is. And then we know that your fraction bar in the middle actually means divide. When you divide, you keep the top fraction as it is, you change division to multiplication, and then you invert the bottom fraction. And so this would be multiplied by 25 over negative 17. The 25's cancel, and we get an end result of negative 4 roots of 21 all over 17. That's the value of tangent of the double angle. Now, let's just say for a moment, just simply for sake of example, let's say that we hadn't used the equation sine 2 theta over cosine 2 theta. So let's say alternately. Okay, the alternate formula for tangent is tangent of the double angle is equal to tangent of the single angle over 1 minus tangent squared of the single angle. Looking back at our picture that we had drawn above, our picture looks something along these lines. We had 5 as the hypotenuse, negative 2 as x, and then negative square root of 21 as y. Okay. We know that tangent is equal to y over r. I'm sorry, y over x. Tangent of the single angle, which is this, would end up being negative square root of 21 over negative 2. On the bottom, we'd have 1 minus the value of tangent squared, negative square root of 21 over negative 2. Okay, simplifying, first of all, I can cancel the 2's. I can also cancel the negative signs. That would end up being positive. So the top ends up being positive square root of 21. On the bottom, I have 1 minus, the 2 negatives cancel. I square that fraction. When I square a root, I just end up with 21. When I square 2, I'd end up with 4. Okay, on this particular one, in the denominator, I need a common denominator. So I'd have square root of 21. This would be 4 fourths minus 21 fourths. Alright, well 4 fourths minus 21 fourths, that ends up being negative 17. So I have square root of 21 over negative 17 fourths. And then once again, to simplify this out to something prettier, we keep the square root of 21 and we multiply by the flipped version of the second fraction. So we have 4 square roots of 21 all over 17, and it's negative. And we notice that that's the same result as what we got way back up here. This particular problem, the reason I show you the alternate formula is if the problem simply asks for tangent of 2 theta and you have not already found sine of 2 theta and cosine of 2 theta, you need to know how to do this alternate formula.